Good evening, good afternoon, good morning, good day, wherever you are in the world, and welcome again to another stream on Freaky Physics. Today we have Ariana. We're gonna do math, so let's let her in. Hi, Ariana.
Hello.
How are you today?
Good morning. I'm good. How are you?
Doing good, thank you. Uh, Hold on. Let me just copy the Jamboard stuff here. While I'm doing this, what are we doing today?
Um, so right now we have recently went back kind of into like geometry kind of thing, like trigonometry.
Mm-hmm.
So we're like doing like the cosine, sine, tan, and also like the inverse kind, I think of it, and also like initial side, terminal side, reference angle with like pi and stuff.
Oh, all right, those things. Okay. You have
Yeah.
anything that we can use?
I didn't like we've gotten were like these IX. All the most homework we really got were like these IXLs, but like I don't really know how to send you those stuff. So
Mm-hmm.
it's base, but like no, not really.
All right. So how will we carry on today? Let me just figure something out. Hmm. All right. So again, okay. So again, we have trigonometry.
Mm-hmm.
So we have sine, cosine, tangent, and then the inverses.
Mm-hmm.
And then we have angles,
Like the
basically.
CSC.
Yeah. So those aren't the inverses.
Mm-hmm.
Those would be. Let's just put that up here. That's gonna be uh cosecant here, CSC. You see, this is gonna be the second here, and this is gonna be the cotangent here. Okay, and then we have angles,
A little.
like that. We have two angles going this way. We have the initial and terminal sides.
Mm-hmm.
Anything else I missed? Hmm. Is there anything else I missed, or is this basically it?
That's basically it, but I mainly want to work on like maybe like the triangles, like the sin, cosine,
Yeah,
tangent,
I'm gonna
and like
guess,
stuff like
cause
that because I was kind of struggling on that part.
yep, all right. Cause I'm also guessing the second one, the one about angles. It's more like memorizing what the terms mean anyway, so it's fine. We can skip that. We'll focus on that sine tangent. Well, the trigonometric quantities. Okay.
Okay.
All right. Let me just get
Mm-hmm.
that up.
Yeah. Geometry.
Okay. So let's do. So okay, you understand how this all goes though, right? Like
It's
what
kind of
side?
like the right triangle.
Mm-hmm. So whatever we do here, we always start with a right triangle, right? Because in
Mm-hmm.
trigonometry is essentially that the study of right triangles.
Mm.
So that's whatever angle you have, we know that this should be a right angle. And let's say that this is your angle. Let's say X for now, right?
Okay.
Okay, now let's label the sides. We know that the sides of a triangle, we have a special name for this longest side here. This is the hypotenuse.
Hypotenuse.
Okay, and these other two, we will call this side, the one at the bottom, this is the adjacent side because it's adjacent to the to
Mhm.
X.
Yeah.
Adjacent, adjacent to X, and this is opposite X, right?
Mm-hmm.
Okay. The idea here is that there two are actually defined straight away. Okay. So the sine of X is defined straight away. Okay. This
Mm-hmm.
is equal to the this is the ratio of the sides, the lengths of the adjacent side over the hypotenuse.
Mhm.
Okay, so this is always a ratio, so no matter what you do, if you I'll explain later why this ratio is going to be important. Okay, and then we have the
Okay.
cosine of the angle, or cosine of x. Let's use the full word first. Cosine of x, right?
Mhm.
Okay, cosine of x is going to be equal to, this time it's defined as the length of the opposite side divided by the hypotenuse. Okay,
Okay.
so these two are the actual true definitions. The others are also defined, but we can define the others in terms of sine and cosine.
Mhm.
Okay, so these are the I'm gonna say these are the true definitions.
All right.
Okay, it's not true in the actual sense of the word, but we'll call it true because we can't really define the rest without knowing these two. Okay,
Yes.
now the reason why this is a ratio, why this ratio is important, is because if you have a smaller triangle, let's say they have a similar triangle, so let's say
Mhm.
these two are similar, right?
Mhm.
Then if there's that similar, then that should also be angle x, right?
Mm.
Similar, let me just fix that. Okay,
Yeah.
okay, so if that's also angle x and this is also the right angle, then this would kind of mean that, let's say, let's put a letter to this. Let's say this is a and b here, and then this is a prime and b prime here, and then hypotenuse, let's call that
Okay.
c, so this will be c prime, right?
Mhm.
Okay,
Yep.
if we don't do the ratios, we can still kind of get the ratios that the ratio of a over b, or a over c for that matter, should be equal to a prime over c prime,
Mhm.
right? And similarly, we can also have b over c should be equal to b prime over c prime, right? So
Yeah.
this idea of ratios is what's important here. And just by defining, and then these, we can define these ratios in terms of where they are relative to the angle. Okay, so relative to angle.
Mhm.
Okay, if we don't put the angle into consideration, we'll always have to take these ratios, no problem, but it's gonna take some time,
Mm.
right? But once we
Mhm.
involve the angle in here, it's gonna make the math a lot easier later on. Now we just have to know what the definitions are. Okay,
Okay.
all right, so that's the key idea. But now let's focus now on what the six functions are. So we have the sine, that's
Mhm.
um, opposite over hypotenuse, right? We have the
Yep.
cosine, and I'm gonna put the cosine here.
Is it
Let's put
Sakatoa?
x. Yep, you've learned that, I think, right? This is the
Yes. Ooh,
adjacent
that's
over hypotenuse,
in hypotenuse.
and then the tangent of x would be equal to what?
Um,
From what you,
opposite and adjacent. Wait.
correct, opposite
Yeah.
over adjacent, right?
Toa.
So exactly. Now the thing here is we also need to define the second. Actually, I don't want to put second there. I'm gonna put second beside cosine.
All right.
Okay, the second of x, also called sec x, right? Then we're gonna define the other
Okay.
one. This is the cosecant of x, or
Cosecant.
this is CSC.
Looks like the two should be swapped.
Yeah, it looks like it, doesn't it? But
Yeah.
I don't know why, but the definitions kind of lend themselves to this kind of arrangement. Okay, of course this would be
Mm.
cotangent, right?
Yeah. That
Cotangent
makes
of
sense.
x, this one makes sense. Sorry, cotangent would be cotx. Okay, this by definition is the hypotenuse over the opposite side, right? So you see why I'm pairing
Kind of
this
like
up.
it's swapped.
Yeah, you see why I'm pairing them up, right?
Yeah.
Also, this is the reason
Yeah.
why these are paired up, because this is just equal to the adjacent side over the opposite side.
Mm-hmm.
Okay, so that means these two are paired up. This is going to be equal to the length of the hypotenuse
Um,
over the
and the
adjacent.
adjacent
Okay,
adding the denominator.
all right, so that's it basically. All right. Um,
Yeah.
okay, so now what we're going to do is instead of measuring, because normally when we do triangles, we measure the sides and then we measure the angle, right? With trigonometry, we
Mm-hmm.
measure the angle first and then we kind of like look for the side lengths from there.
All
Okay.
right.
All right. So, with this in mind, let's go on and I'll give you a full example here. Okay. Let's say I'm going to give you this
Mm-hmm.
triangle and I'm only going to give you two things. I'm giving you the angle. Okay. And this is where you will use your calculator. Let's say that this angle is 20 degrees.
Mm-hmm.
Okay. And I'm going to give you, well, you pick which side do you want and what number do you want to use for it.
I want to have
You can have either A,
that.
B, or C.
I want C.
Okay, let's put C in. Is C gonna be useful? I think so. C. What number would you like to use here? Don't use 5.
Okay. Um,
Well, actually, we can use 5. It's
7.
fine. Okay, let's put 7 in here. 7 units. Okay. So,
Mm-hmm.
what I want you to do now is find A and B. So find A and B, and find um. Okay, find A and B through um sine, cosine, or tangent. Okay, so that's the first
Mm-hmm.
thing I want you to do. Of course, you can just you can just use the calculator here. So I'm gonna allow the calculator here, right? Okay,
Yeah.
here on this part. Okay, the second bit
Okay.
is I'm
Okay.
gonna ask you to calculate the second, the cosecant, and the cotangent of 20 degrees. But in this case,
Oh.
no calculator.
All right.
All right. I think the first one's pretty easy enough.
Mm-hmm.
Okay. So, what are the measures of A and B? Which one would be the most useful? Sine, cosine, or tangent?
Not tangent.
Not tangent is correct.
Yeah. Um,
So, we'll cross that out now, right?
I like. Okay. Yeah. And I want to do sine first.
All right, sine
Yeah.
first.
So it's like sine. Actually, I could just put this in my calculator, I guess.
Mm-hmm.
Let's do that.
Let's go
So
do
it's
it.
sine 20.
Mm-hmm.
I'm just gonna write it out just so that I know that.
Okay, go ahead.
And then it's um hypotenuse at the bottom
Mm-hmm.
and A on top, right?
Right, correct.
Mm-hmm.
Remember, that's 7, not
So
17. Yeah.
oh 7.
All right.
Oops, sorry.
Let me just redo the 7 here too.
Mm-hmm.
There.
And you times the 7 times the sine 20, yeah.
That's correct.
Mm-hmm. So I get 2. Oh wait, no, that's that's not
Mm-hmm.
2.39. Yeah.
Okay, great. Now I'll
I
just do
think.
this here on screen just so we're clear. So we do again. We take the sine of 20. So sine would be here. And then we multiply that by 7. So times 7. And there's the answer. 2.39 is correct. Great.
Yeah.
All right.
Mm-hmm. Yeah.
Okay, how about B?
So that would be cosine.
Mm-hmm.
So cos 20 b over 7.
Correct.
Yeah.
Mm-hmm.
Times 7
Okay.
equals 6.78 rounding.
Okay, correct. 6 point.
Mm?
Actually, no, not quite. I got a different answer.
Really?
Yeah, I got 6.58, not 7.8.
Oh shoot! I didn't see the 5. Oh shoot.
Okay, no worries. So this is okay. No worries. That's correct. Okay, let's move on.
Yeah, I'm like literally looking. I'm just like, oh.
Shall I? I think I'll allow a calculator now because the numbers aren't easy to work with, right? But okay, use a calculator, but don't use a trigonometric functions on the calculator. So no trigonometry
So
in
not the sin
calculator.
cos tan.
Yep. So what I want you to do first is uh just find the ratios again. So how do you find the second again?
Second is
So I'll just put it here.
the opposite of cosine, right?
Correct. Sec.
Oh wait, where should I put it there?
Mm-hmm. So
Um,
cosine is
is 6. Cosine is 6.58 over
mm-hmm.
7, so it should be 7 over 6.58.
Right.
Do that.
Mm-hmm. So
CSC.
okay. Oh, you're writing it there already. Never mind.
Oh shoot.
Go ahead.
Sorry.
It's fine. It's fine. It's fine.
Is the opposite of sin or
Mm-hmm.
sine.
Mm-hmm.
So 7 over 2.39.
Correct.
And cot just the opposite tan, which is adjacent over opposite.
Mm-hmm.
6.58 and 2.39.
Okay. Correct. All right. And finally, just find the values. You can now calculate these values. Okay, so while you do that, let me just put that up again. So again, second would be hypotenuse over adjacent, which is that. Cosecant would be hypotenuse 7 divided by opposite, so A. And cotangent is going to be adjacent over opposite.
Okay, yeah.
All right, great.
Okay, what am I? So I'm trying to find
The final
Wait,
answers.
what am I trying to find?
Just find the final answers to 2 decimal places.
Oh, 2 decimal?
Mm-hmm.
Okay. The 1.06 2.93
Mm-hmm.
and 2.75. Yeah.
Okay, all right.
Yay.
Okay. Okay, so that's pretty easy. So I'll give you one more, and then after.
All right.
Okay, I'll give you one more set of problems, and then afterwards, I'm gonna ask you something. Okay, so for now,
All right.
let's put a triangle going this way. Okay, and let's say that this is now. Okay, I'm gonna put here 60 degrees. And I'm gonna
Mm-hmm.
give you. I'm gonna give you this.
You gonna choose my numbers?
Okay, I'll give you this. I'm gonna give this. Make this 5.
Okay.
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 All right. So find the Oops. Find the hypotenuse C, and find A. Okay. So find A, C, and secant of 60 degrees, cosecant of 60 degrees, and cotangent of 60 degrees,
Mm-hmm.
and tangent of 60 degrees.
Everything.
Yeah, except sine and cosine.
Yeah.
Okay.
Okay.
All right. I'll just paste something onto the next page.
So CSC is
Again, you find A and C first.
oh yeah, A and C.
Mm-hmm.
um so I'm gonna do tan to find A.
Mm-hmm. All right. Good. So you can use tangent to find A.
Wait. Yeah, it's opposite and then 5.
Okay. I think I'll just remove tangent here. Okay, just those 3.
This is 8.66
Mm-hmm.
and you can find
Okay.
C with cosine. Yeah,
Right.
cosine.
Correct.
So, oh wait, no, I forgot 60. 60 equals C 5.
Okay. So your A is correct.
We would divide. We would divide 5 by cosine of 60. Yeah.
Mm-hmm. Yes, to find C.
Dot 10.
Okay. And we do that. Times
And
10.
then
Correct.
mhm,
Okay. All right, then.
CSC. Oh, sorry.
Go ahead. Go ahead.
CSC is the opposite of. No, wait, no, that's S. Wait,
Just think
I
of it
can't
like the.
read.
Think of it like S and C always go together.
Yeah. I'm just like looking at the two. I don't know. So the top one's SEC and the
Yeah, I'll just
middle one is
rewrite that.
CS.
Yep, I'll
Sorry, because
rewrite that.
I was like looking and yeah. I'm sorry. I just
No
couldn't
worries,
read what
no
I was saying.
worries. Sorry about that. I'll just rewrite everything
Okay.
just to clarify
Thank
that. There you
you.
go.
So SEC is the opposite of um cosine. No, cosine. Yeah,
Cosine,
cosine.
correct.
Yeah.
Yep.
Okay. So that would be 10 over 5,
Mm-hmm.
which equals 2. 2.
Correct.
And CSC is the opposite of sin or sine,
Right.
which is 10 over 8.66.
Mm-hmm.
And simplify that. 1.15.
Uh-huh. All right.
And then this is the opposite of tangent, which is 5 over 8.66
Mm-hmm.
equals 0.58.
All right, all correct. So let's just put that in the calculator just to show everyone. So 8 divided by 8.66. We have that. And then, so 1.15. And then, uh, we have 5 divided by 8.66.
Mm-hmm.
That's gonna give us 0.58. All right, so correct. Okay. Um, okay, I'm gonna go now to the next bit. I think I'll skip the other one for now, the one I'm thinking of. Let's go straight to this thing. I just wanna ask you now, have you learned any of these equations? I guess we've done this
Um,
one. We've done this one, right? And we've also
mhm,
done this one. We just did that.
yeah.
Okay. Oh, actually, no. We have this not quite yet, right?
Hmm.
But have you learned
Like,
that
I
one?
think I don't. Maybe the even odd identities. Maybe
Even on this one.
I don't know. I think maybe, but I don't
So,
really think so. So,
okay.
um,
So the co the co-function definitely not yet, right?
hmm,
Half angle not yet, right? I'm gonna guess that Pythagorean identities is a maybe.
yeah.
Okay, so we'll go straight to this one. Okay, actually, we'll go through these three. Okay, even though I know you learned the first two, I'll just recap them briefly, and then we'll go straight to the Pythagorean identities. Okay, now
All right.
let's take a look at y tangent. Let's use x in this case. Yeah, y is tangent x equal to sine x over cosine x, because sine x, as we know, is the opposite over hypotenuse, right? And then we're gonna
Hmm.
divide that by the adjacent over the hypotenuse, which if we
Mm.
rewrite, it's gonna be opposite over hypotenuse times hypotenuse over adjacent, right? So the
Hmm.
hypotenuse cancels out, and that leaves us opposite over adjacent, which is the definition of tangent.
Yeah.
Okay. Now a similar thing will happen with these other ones. The cotangent will be you just reverse it, just flip it over, and then cosecant and secant. Basically it's should be obvious there, right? Right.
Hmm.
So I'm gonna just remove clear this now. Now let's go now to this one, the Pythagorean identities.
Hmm.
Okay. Again, let's just do this briefly. So if you have a right triangle like this, okay, and let's put our angle x here again, and that's ABC. We know something for a fact. Before we do anything with this, we know that a squared plus b squared should be equal to c squared if this is a right triangle,
Right
right?
triangle.
Mm-hmm. This is the
Hmm.
Pythagorean theorem, right?
Hmm.
Theorem. Okay. Now, thing here is what we'll do is we can divide by a squared, b squared, or c squared, right? Okay.
Mm.
So what we'll do is we'll divide it by c squared first. So if we divide everything by c squared, we get a squared over c squared plus b squared over c squared equals 1,
Hmm.
right? But what is, I'm going to just write this now. I'm going to remove the squared here and the squared here and put that in brackets first before squaring that. They mean exact
Hmm.
same thing, right? But we have defined
Hmm.
what a over c is. What's a over c? Let's go back here. A
Like,
over c would be,
mhm, the adjacent over hypotenuse.
so this would be cosine x, right?
Hmm.
Cosine x squared plus similarly this other one, b and c.
Sine squared.
That's sine squared. So sine x, then you square that, and that's equal to 1. Now, just so we're clear, we have, this is a definition. Okay, this is not an operation, but this is actually a definition. So this goes for any trigonometric function. I'm going to use sine here. Sine of x squared is the same as saying sine squared x. Okay. So it goes with everything else. Cosine, tangent, whatever. Okay. So we can rewrite this as cosine squared x plus sine squared x is equal to 1. And this is the Pythagorean theorem in trigonometric form. Okay, so again, Pythagorean theorem in trigonometric form. Now, this is a very nifty shortcut to know anywhere. So once you memorize this, you can always use the shortcut. Especially, I don't think you join Olympiads, like math contests, right? But
No,
if you
I
do,
don't.
but I'm just gonna tell you that if you do, this is a very good tool to use in those contests because it's actually like one of the shortcuts you can use.
Ooh.
Okay, so all right, so that's the first one. Now we can divide with either a or b, right? So let's just do it on the other side. So put it here, that's a squared plus b squared equals c squared. We'll write it here as well. Now, if we divide both sides by b, we get a squared over b squared plus 1 is equal to c squared over b squared. What's a over b? That's tangent, right? Actually, is it? No, not quite. It's
Yeah, because it's like, oh wait, it's
it's,
cot.
it's
COT.
cotangent. Yeah, it's COT here, right? Okay.
Cotangent.
Yep, that's cotangent squared of x plus 1 equals c over b is hypotenuse over b is
Hypotenuse is over. That's a hypotenuse over opposite, right? So it'd be CSC.
that's CSC. Okay, so this is another possible way to write this. So in other words, we can write it like, actually you can leave it like that. Okay, now on this other side, if we divide everything by a squared, forgot the squared there, so it's gonna be 1 plus b squared over a squared equals c squared over a squared. So another way of writing it, c squared over a squared would be, c over a would be secant, right?
So that's sec.
Sec squared x here, and then 1 is still here. Then b over a would be cotangent again. No, tangent.
Cotangent. Oh no, tangent.
That's gonna be tangent. So plus tangent squared x. So this is another form of the Pythagorean theorem in trigonometry. So that's why if we go back here, we have these 3 formulas. Which one's the most useful one usually? It's the first one that's the most useful. Okay, but knowing the others,
Hypotenuse.
yeah. Okay, all right. So I'm gonna ask you something now. Well, now what can you do with these identities? You can actually either actually use the trigonometric, sorry, not the Pythagorean theorem with it straight away, or you can just use the relationships to find certain values. For example, you're given cosine of x is equal to 0.2. Cosine of x is equal to 0.2. 0.2. So from here, you can actually find sine x, then you can find tangent x, and then you from tangent x, or you can actually find the other 3. So cosecant, secant, and tangent, right?
Mhm.
Okay, so I'm gonna give you this value.
Mhm.
Let's do it one by one. Find sine x.
Sine x.
Uh-huh. Okay, I think
Mhm.
I'll take a screenshot of those formulas first before we do anything else. Screenshot. So it's easier. So we can just
Maybe-
carry it over to the other pages. There we go. Okay. So just keep that in mind first.
Mhm.
Mhm.
And so we're doing the top one, right?
Yep, correct.
Please. Let me.
And in this case, just keep it as a square root if you have any square roots. Okay.
Mhm. Would just be like that,
Mm-hmm.
just like that.
Mm-hmm. That's right.
Mhm.
So what's next? You find sine x now. Not quite yet.
Okay.
All right, I'll help you out with this first. Yeah. What you can do
Okay.
here.
Yes, please.
All right. What you can do here is again, you always try to move any terms that you can move first before taking a square root,
Oh yeah.
right? So
Mhm.
we can move this first. So I'll put here sine squared x equals, well, we'll do the squaring right away. 0.2
Mhm.
squared is 0.04. So I'm going to write that straight away. 1 minus 0.04. And that's going to be equal to 0.96. Okay?
Mhm.
And this means from here that sine of x is equal to the square root of 0.96. That's it.
Okay.
Okay. Of course, I think we can express this. What's okay? I think this is 24 times 4, but 24. This is 16 times 6. Okay. This is square root of 16 times 6. 6 has no square root, but 16 does. So that's going to be 4 square root. Actually, no. I forgot something. Over 100. So that's going to be 96 over 100. So this is where it becomes more mathematical now. More advanced math. You're going to have to express these numbers in terms of a square root and some ratio. So I'm just going to write that as 96 over 100 and take the square root, right? So
Mhm.
100, the square root of which is 10. So I'll just write there 10 in the denominator, right? And then this
Mhm.
is going to be 96, like I said, is 16 times 6. Yeah, 16 times 6,
Mhm.
which is, if we take the square root, that becomes 4 root 6. So finally, the final
Yeah.
answer here would be sine x 4 over 10. That gives us 2 over 5, right? That 2
Yeah.
root 6 over 5. And that is the final answer. No calculator
Mhm.
required.
Yeah.
Okay. All right. So given so that same idea would work. You just have to use the proper formula here. Can I just ask you to do tangent and
Mhm.
one of these? I think I will select second.
Mhm.
Okay, go ahead.
Wait. So it's just do we just plug it in the equation, yeah?
Right.
So what's the number?
All right. Well, you're given cosine x, so you can get second x
Mhm.
from there, right?
Oh yeah. Um. So cosine. Wait. Why am I? Sorry.
Okay.
Um.
Need some help or you can do it. Can you do this?
Is it? I'm just. the 0.2, just
Mm-hmm.
like
That's
um,
correct. That's correct.
okay. I was just like, okay, is it that? I don't know.
Mm-hmm.
So can I go to the next slide?
Okay, sure. We'll do that. So I'll just write that here. What is
Okay.
given that cosine x is equal to 0.2? Find tangent of x. Bless you.
Sorry.
All right, I'll just copy this again onto that slide.
2 plus 1.
Mm-hmm.
Mm-hmm.
Right.
So this would be 0.04 over, or well, 1 over 0.04, yeah? Technically?
Yeah, but there's an easier way to do it. Why don't you do the division first before you square it?
Okay.
Because that's easier, right?
Gives 5,
Uh-huh.
and then it goes to 25.
Uh-huh.
And then we minus the 1 to move it to the other side.
Right.
Makes 24
Correct.
equal tan 2.
Tan squared of x. All right, good.
Then you square root this, and I
Mm-hmm.
don't think that is like a perfect square root, so you have to like do
Find
the weird root thing.
uh-huh. Find the factors of it, right?
Yeah.
Mm-hmm.
So 2, 12, 3, 4,
Okay. You got 4
2,
already. 4 is a
2.
perfect square, right?
Oh yeah, yeah.
Okay.
So we got 2,
Mm-hmm.
2, 6
Right.
equals tan. Yeah.
Yep, done.
Oh yeah.
Nice.
I'm just
That was
I got
that
stuck at the beginning.
that was you got really excited on that one. All right.
I am I just like knowing I know stuff.
All right. So let's just let's just box that and say that's tangent x. Right? Done.
Hmm. I just
Uh
got a little confused at the beginning because I'm like, what do I do?
okay. So the thing about this now is this usually just forces you to think of all these numbers in terms of square roots or easier numbers to work with. But aside from that, it's pretty
Hmm.
straightforward.
Yeah.
Okay, just follow these formulas and you're good.
Hmm.
The next bit, I don't want to go there yet. I'll just let you practice first. But I want to say this before you practice again, yeah?
Hmm.
These
Yeah.
other ones, the odd even identity, the odd even identities are a bit easier to explain once we put it into a coordinate system. Okay, but these
Hmm.
other two, the co-function identities and the half angle formulas, these require formal proofs, and most of the time you have to either try to know what the proofs are or you're gonna have to prove it yourself.
Okay.
Okay, so these two require proofs. Okay,
Hmm.
this just requires the Cartesian plane to
Hmm.
understand. Okay, Cartesian plane. So in other words, later on, once you're actually using these for the co-function and half angle identities or formulas, they're usually given to
Hmm.
you already, so you don't have to memorize them. Or if you do, then yeah, you're a bit you're in trouble.
Oh no.
All right, but normally they're given, so don't worry about it. Okay.
All right.
The thing that you would need to worry about these would be the proofs. Okay.
Hmm.
All right. I'll give you one more. Okay, this time I'm gonna combine the problems. Okay, so I'm gonna give you a triangle.
Okay.
Gonna give you this triangle here for now. And Okay, I'll give you an angle. Okay. Let's say that this is... Okay, I'll give you one of the special angles. This is 30 degrees. Okay. Uh, okay. If that's 30 degrees and I'm gonna give you the hypotenuse. Hold on. This is gonna be 4. Okay, so find. Actually, I better give you another value. Hold on. Let me think. Which one do I give? Okay, okay, this one's correct. 2 square root of 3. Okay. Oh, special angles. I think if we have time, we'll do special angles, but otherwise we'll do that next time. All right. So given these, find sine theta and hold on. Let me see. And tangent theta.
Is this special angles like the ones that don't have like this, the I don't know.
Okay, the special angles are basically, I'll just tell you what the values of the special angles are. 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So, okay, so find sine theta and tangent theta. This is theta equals 30 degrees, yeah? Using the Pythagorean theorem for trigonometry. So no calculator here.
So to find like the thing, you have to, so it's 4 squared equals
That's one approach. Good.
this would be 4 and this would stay 3. So that would be 12. This would be 16 minus 12 is 3.
No, it's not 3.
No, not 3. Wait, okay. I made it look like a 3.
Okay, 16 minus 12.
4.
4. Right. So root 4 would be?
So this would make it 2.
2, correct.
Yeah.
Right. So what's sine theta and tangent theta? And cosine theta for that matter. I'll add that. Right. Sine theta, cosine theta, and tangent theta.
2, 4. Yeah. 1/2.
Right.
Cosine would be 2, 3, 4. These two can like not cancel out, but like they can separate. Simplify, I mean.
And finally,
tan. Yeah, opposite.
Yep.
First. And then adjacent, which may these two like actually cancel out. Wait a second. We're not allowed to have the square roots at the bottom, right?
You're not allowed to. You're correct. But at the moment, I'll allow it. Then I'll show you how to take it out. Okay.
Okay.
All right. So you're left with 1 over square root of 3, right? So. Okay. Now, how do you remove that square root from the denominator? You multiply both sides by square root of 3. Why? Because
square root of 3 squared gives you just 3 in the denominator, right?
Mhm.
So the next thing you do is you multiply 1 and square root of 3. It's going to give you square root of 3.
Oh, whoa. It just magically appeared just as I was writing. Okay,
Oh,
I'm just
okay,
gonna
that's
delete that.
weird. All right, so basically that's for this bit, we'll just practice that later again. Okay.
Mhm.
All right.
Okay.
So, last thing before we end, I'll just extend maybe just a few more seconds. So what you've done is you use the Pythagorean theorem straight away here, right?
Yeah.
Now, another method so that you can use is this. You can say that cosine, I'll just do this only one, cosine of 30 degrees should be equal to um 4, sorry, the other way around. 2 square root of 3 over 4, and that's going to give you square root of 3 over 2, right? Then you can do
Mhm.
cosine squared theta equals plus sine squared theta equals 1. And then you can do the other one for tangent and secant. Okay,
Mhm.
so tan squared theta plus 1 equals secant squared theta. Okay,
Mhm.
all right. This is the solution that we will go through next time.
All
Okay,
right.
all right. So that's it for
Would
today. Yes, we're done.
Yeah. All right. Would we go back to this Jamboard next time so that we can like
Sure,
elaborate more on it?
sure.
Okay.
All right. Oh, and
And
one more thing.
also,
Oh, you go first. You go
yeah.
first.
Oh, okay. I was gonna ask because like my mom was asking if maybe it's because you're in the IB program, right?
Right.
My mom was wondering also if maybe like during over the summer you can like help me out with like how IB tests work.
Yeah, sure. Sure,
Mhm.
no problem.
Or yeah.
Okay. All right. The thing I want to say is next week I won't be available. I'll be traveling.
Oh.
Okay.
Okay. Have fun
All
then.
right. Well, I'll try to. All right. So we'll meet again in 2 weeks. Okay.
All right.
All right. So with that, I guess we can end today's lesson. I'll see you next time, Ariana.
Bye
All
bye.
right. Bye bye. Have a good day.
You too.
Okay. So done for today. So, all right. So that was pretty easy. So for some of you who have studied trigonometry yet, yeah, that's how basically it works. Okay, so going back real quick. Uh there. So again, we have the definitions, and then from the definitions, we can have the relationships. These are the definitions for all the trigonometric identities. And then that's an example. And then I'm gonna highlight this bit here. These are the relationships among the six trigonometric identities. You only really need sine and cosine. Everything else you can derive from those. Okay, and we can do the Pythagorean theorem with um this as well. Okay, so with trigonometric identities. So this is one way to derive it. So the most important one is a cosine squared plus sine squared equals 1, but we have two other forms here. All right. So that's it for today. Hopefully, if you come across this, you get to learn something. And if, yeah, if there's no one on the stream right now, so for now, I will see you all next time. Good evening, good morning, good day, good afternoon, good night, wherever you are in the world. And stay freaky, everyone. Bye bye now. Oh, before that, don't forget to like and subscribe and share and hit the notifications on any of our social media platforms. So, with that, again, stay freaky, everyone. Have a good one.